So, good morning everyone. Today I shall discuss about the performance of transmission line. How the transmission line is performed and why we analyze the performance of transmission line. This we analyze. See, when we generate the electric power from the generating plant, and afterward we distribute this power for the particular consumer, for industry, for housing application, for other application. In between this, there are some things are there. By means of this, we can transmit the power. That means this is the way we can transport the electrical energy from one place to another place. That means from generating plant to the distributing station. In between this, as we just transmit the electric power by means of transmission line, so there are some determination is required. What is the determination? That's why we need to perform, we need to analyze the performance of the transmission line. How much efficiency we can get from the transmission line and how much regulation is there. So these are the determination from the performance of the transmission line. If I consider a transmission line, then basically there are three parameters are there which basically affect on the transmission line. One is resistance, another is inductance and another is capacitance. That means R, L and C. These three parameters basically are predominant on the transmission line. When we consider the resistance, basically the resistance loss is there. Which loss is? We drop, first of drop. If I is the current, basically IR drop we can get from the transmission line. Right? After what, inductance. How the inductance drop is there in the transmission line? Which is I multiply XL. XL is the inductive reactance, which is omega L. That means omega means 2 pi F L. Okay. Similarly, there are capacitive drop is also there, which is I multiply XC, which is capacitive reactance. And also we can write this XC means I 2 pi F V C. Okay. 2 pi F V C. That means from here what we can say, here current is the factor. So in quadrature of the current we get the line inductive drop, and here in quadrature of the voltage we get the capacitive drop. So in that way we can just get the drop, not only the voltage drop, again we can analyze the power loss and efficiency and all kinds of things. Now, as there are three parameters are there, the resistance, inductance and capacitance. So how this parameter will influence of the transmission line? So this is the part of the another parameter. But here, how much value parameter will affect on the transmission line, so that we get and we analyze the efficiency and we analyze the regulation of the transmission line. This is the fact. And there are two types of transmission line is there. The overhead transmission line and underground transmission line. Basically, in overhead transmission line, this inductance will affect much more than the capacitance. Whereas in underground cable system, the capacitor will give more effect than the inductance. Okay. So this will come later on. So before going to the calculation of the resistance, inductance, capacitance, and from the performance of the transmission line. So first of all, I will give the details and the different types of transmission line according to based on their level of voltage and the length of the transmission line. Okay. First up, number 1, the short transmission line. Short transmission line. Number 2 is medium transmission line. Okay. And number 3 is long transmission line. Long transmission line. These are the 3 types of categories of the transmission line. How is classified? These 3 transmission lines are classified according to based on the transmission voltage and their length of the transmission line. In case of short transmission line, if the length is up to 50 kilometer, and voltage up to 20 kV, voltage up to 20 kV, then we consider this transmission line is under the short transmission line category. Okay. So here you see, as the length is within the limit and voltage limit, so obviously there are some actually parameters are there. So according to based on the voltage level and the length, we consider the parameters. Which parameters? The resistance, inductance and capacitance. In medium transmission line, here here the length in between 50 kilometer to 100 kilometer. Okay, 100 kilometer. And voltage level up to from 21 kV to, you consider the 100 kV. Okay, 100 kV. So you see, the length is increased as well as the voltage level is increased. And if the length of the transmission line above 100 kilometer and the voltage level 100 kV, then we consider the transmission line is the long transmission line. So if I consider there are three parameters are there: resistance, inductance and capacitance. In case of short transmission line, as the voltage level is less than the medium and long transmission line, that means here if I draw the diagram of this, see, only resistance and inductance we consider in that case. Here we now consider the capacitance which is formed in between the conductor. Okay. Why? Due to the low voltage, we consider the whatever capacitance is formed, it is negligible and it is considered as lump parameter. So only resistance and inductance we consider in case of short transmission. Here this is your sending end voltage, this is your receiving end voltage. Okay. In case of medium transmission line, as the voltage level is increased up to 100 kV, so here we consider, okay, the capacitance is formed in the transmission line. Practically, the capacitance may be formed over through the transmission line. But here we consider in case of medium transmission line, okay, the capacitance may be formed. It may be formed at the sending end place. It may be formed at the receiving end. It may be formed in between the sending end voltage and receiving end voltage. So according to based on this, the medium transmission line is categorized in three different parts. What is it? The T network type transmission line, the pi network type transmission line, and another is end condenser method. End condenser. Okay. So what is this classified? We consider the capacitance here. So thereby the circuit is like a T-type network. Here we consider the capacitance